So let me quickly show how climate can change because of plate movement. So if we go back a billion years or more, we will see that the plate movements have been causing climate change all along, and we'll see some more details. So I will zoom into our own neighborhood here in India and see how India has moved over time. It started moving 71 million years ago. It was here. I will show in a minute how we know where it was and how fast it was moving and so on and so forth. So this animation basically shows that over the last 70 million years or so, it has been constantly moving towards the Asian plate, and then it crashed into the Asian plate and is now actually continues to push under the Asian plate and pushes the Himalayan mountains. Himalayan mountains got created because of this collision, and the pushing continues to raise the Himalayan mountains by almost 1 centimeter per year. So imagine that. Okay, so how would this have changed the climate? Obviously, if the Himalayas were not there and the Indian subcontinent was not sitting so close to the equator in the tropics, our entire business of monsoon would be very different, right? So the monsoon itself got created by this tectonic movement and the mountain building, plus the monsoonal circulation also created changes over East Africa. Grazing animals evolved related to the monsoon. New types of plants and grasses evolved. So there are photosynthetic pathways called C3 grasses and trees, and C4 grasses and trees. There are some details that I won't go into, but that's how plate tectonics can cause changes in climate. Okay, so I won't go into these. Let's not do this. I want to show one more thing. So plate tectonics. So you can see, we can also go back in time and see that all the continents were actually clustered together. In the 1920s, when Alfred Wegener for the first time looked at South America, North America, Europe, and Africa and said they seem to fit together and that continents move, people thought he was crazy. They made fun of him. For the longest time, actually till he died, it was not completely accepted that plates actually move and they're floating on top of the mantle. Amazing, right? And now we know that all the plates are moving, and in about 50 million years ago, we'll all be heading towards the North Pole and then back towards the South Pole and so on and so forth. So Pangaea, going back to about 200 million years ago, started to split up and get organized into different named configurations, and here we are now in the current configuration, and this is 50 millions into the future. So you can see India continues to push, become smaller. North America, South America, Australia, everything will continue to move north. Okay, Antarctica does not do that so much. Australia is zipping along northward at about 3 centimeter per year. Okay, I don't know what I said about Himalayas. It's about 1 centimeter rise per year. Okay. So Australia, at some point, New Guinea, they were all south of the equator, so the Indian and Pacific Ocean were connected. When Australia moved and blocked this connection, rainfall over East Africa changed, and there is some evidence, good hypothesis, that this change in vegetation and rainfall over East Africa actually led to the evolution of so-called bipedalism, which means most of our ancestors, primates, walk on all 4 legs. We started walking upright. We means our ancestors. Okay, so climate change had something to do with our own evolution. Okay, those are the kind of things that tectonic timescale changes do. This is just showing the constant formation of ocean plates. I won't go into the details, but you get the idea. Ocean crust is constantly getting formed, and new ocean crust gets formed, which means the oceanic lithosphere keeps sliding away from the so-called mid-oceanic ridges where new plates form, and the plate then subducts under the continental lithosphere, causing the so-called ring of fire that we looked at in the Pacific, with why it is so active. And volcanic islands like the Galapagos and Hawaii can get formed, but if the plate keeps moving, the supply of magma stops, so the volcanoes die and they just collapse or become dead volcanic islands. So you can see the entire island itself is moving here and becoming part of the continent over time, and so on and so forth. So these obviously are geologic timescales which are millions of years. Sudden changes happen sometimes due to earthquakes, like we talked about off of Java and Sumatra in 2004, that changed the continental configuration, and we said entire Japanese island moved by a few meters because of the 2011 earthquake, and so on and so forth. Okay, so main message: tectonic changes can create climate change, which can be significant. For example, appearance of monsoon. That's not a small change because it is registered in changes in vegetation, in life forms, and continental movement of Australia changing the climate over East Africa and leading to our evolution is not a small change, right? So life, climate, and continents have all changed, evolved together, and this is something that is often referred to as geobiosphere. So life on Earth has not only depended on the greenhouse effect that we talked about as being ideal compared to other planets, but also because of this recycling of material and continents and changes in climate and so on and so forth.